Example 3, let fx is equal ln x plus 2, determine all vertical asymptotes that the graph of f has. For this one we know that ln x plus 2, it is just the graph of ln x, but it is shifting to the left by 2 units. So the blue one here, it is the graph of ln of x, and this one, the gray one, is for the graph of ln x plus 2. If you see the graph, the blue one, which is for ln x, the limit of ln x when x approaches to 0 from right, it goes to minus infinity. So this function, ln of x, has a vertical asymptote when x approaches to, it has a vertical asymptote at x is equal 0. And this one is the graph of ln of x plus 2. It is the same graph, but it is shifting to the right, to the left by 2 units. So if here x is equal to 0, the vertical asymptote, here the vertical asymptote will be x is equal minus 2, because the limit of ln x plus 2 when x approaches to minus 2 from right, it goes to minus infinity. So the vertical asymptote for the graph ln x plus 2, it is x is equal minus 2. Since the limit of this function when x approaches to minus 2 from right, it goes to minus infinity. Example 4, determine all vertical asymptotes that the graph f of x is equal x squared minus x over x squared minus 1 has. We said any function has a vertical asymptote if the limit of this function when x approaches to a is equal plus or minus infinity. Since this one is a rational function, we can take the zeros of the denominator and then check the limit of the function at that zeros. If the limit goes to plus or minus infinity, we conclude these zeros are vertical asymptote. So fx has a vertical asymptote if limit of fx when x approaches to a is equal plus or minus infinity. And here we have x squared minus 1 in the denominator, so x squared minus 1 is equal to 0 if x is equal 1 or x is equal minus 1. Then after you find the zeros of the denominator, you have to check the limit of your function. Is it plus or minus infinity at that zeros? So we need to check the limit at these points. Limit of x squared minus x over x squared minus 1 when x approaches to 1. If you factorize this one, it will be, take x as a common factor, so it will be x multiplied by x minus 1. And this one, you will take the square, so it will be x minus 1 multiplied by x plus 1. Then you will cancel x plus x minus 1 from the numerator with x minus 1 from the denominator. You will left with x over x plus 1. So now the limit when x approaches to 1, just you need to replace x by 1, you will get 1 over 1 plus 1, 2. So the limit when x approaches to 1, it is equal to half, which is not plus or minus infinity. So the function doesn't have a vertical asymptote when x is equal 1, since the limit is equal half. Now let us check when x approaches to minus 1. So we have the same function, we factorize our function, and we left with the limit of x over x plus 1 when x approaches to minus 1. If you replace x now by minus 1, you will get minus 1 over minus 1 plus 1, which is 0. So minus 1 over 0 is either plus or minus infinity. So since here we get that it is equal plus or minus infinity, we conclude our function has a vertical asymptote at x is equal minus 1 only. يعني إذا كانت عندنا rational function وبغينا نجيب أصفار المقام على أساس نحدد الفيرتيكال أسمتوت، بعد ما نجيب الأصفار لازم نتأكد هل الليمت عند هذه الأصفار يساوي بلس أو ماينس إنفينيتي. إذا كان الليمت يساوي بلس أو ماينس إنفينيتي، إذا على طول نقول الفانكشن هذا فيرتيكال أسمتوت عند النقطة. لكن في حالة إنه الليمت ما ساوى بلس أو ماينس إنفينيتي، اللي هي نفس الكيس لما الإكس أبروش تو 1، لاحظنا تزيك والهاف، والهاف لا بلس إنفينيتي ولا ماينس إنفينيتي، إذا هنا نقول الفانكشن ما عندها vertical asymptote عند ال 1. لكن عند ال minus 1, since the result is plus or minus infinity, we conclude this function has a vertical asymptote at x is equal minus 1 only. we will move to horizontal asymptote. We have two types. The first one vertical asymptote, and we talk about this one. Now we'll move to the second type, which is called horizontal asymptote. This is definition 252. A line y is equal L is said to be a horizontal asymptote for the graph of a function f if at least one of the two statements in 9 is true. If either limit of fx when x approaches to minus infinity is equal L, or limit of fx when x approaches to infinity is equal L. So here we have the line y is equal L is a horizontal asymptote if limit of fx when x approaches to minus infinity is equal L, or limit of fx when x approaches to infinity is equal L. يعني في التعريف الفيرتيكال اسيمبتوت قلنا الناتج يساوي يا بلس انفينيتي أو ماينس انفينيتي، فبيكون الفيرتيكال اسيمبتوت x is equal a. بينما في الهوريزونتال اسيمبتوت نجيب الليميت لما الاكس approach to minus infinity أو plus infinity. إذا الناتج يطلع عندنا L، إذا بنقول y is equal L is a horizontal asymptote. يعني لازم نفرق بينهم. في الفيرتيكال اسيمبتوت المعادلة للفيرتيكال نقول x is equal، بينما في الهوريزونتال اسيمبتوت نقول y is equal. نفس الشيء في الفيرتيكال اسيمبتوت ناتج الليميت هو اللي يساوي بلس أو ماينس انفينيتي، لكن في الهوريزونتال اسيمبتوت نجيب الليميت عند ماينس أو بلس انفينيتي. طبعا إذا الناتج يطلع عندنا هنا بلس أو ماينس انفينيتي إذا ما هوريزونتال اسيمبتوت، لازم الناتج يكون exist ويعطينا قيمة محددة اللي هي L. So here we have three graphs show the horizontal asymptote. For the first graph, f of x approach to L as x goes to infinity. So if our x goes to infinity, we see this graph as a horizontal asymptote which is y is equal L. And for the graph B, f of x approach to L as x goes to minus infinity. So if your x goes to minus infinity, your function has a horizontal asymptote which is y is equal L. And for this graph, if fx approach to L as x approach to minus infinity, and fx approach to L as x approach to infinity. So if you goes to infinity, the graph of your function approach to L. And similarly, if you go to minus infinity, the graph of your function approach to L. So y is equal L is a horizontal asymptote. And for this one, fx approach to L1 as x approach to minus infinity, and fx approach to L2 as x approach to minus infinity. So if you go to minus infinity, the graph approach to L1. If you go to plus infinity, your graph approach to L2. So this is a graph for a horizontal asymptote where you take the limit when x approach either to plus infinity or to minus infinity. So note here, in general, if r is a positive rational number and if x minus a power r is defined, then limit of 1 over x minus a power r when x approach to minus infinity it will be 0, and limit of 1 over x minus a power r when x approach to infinity it will be 0. So if r is any rational positive rational number and you want to find the limit of this function 1 over x minus a power r as x approach to minus infinity or plus infinity, the result will be 0, and you conclude that this function has a horizontal asymptote at at y is equal 0, where our L here it is 0, and the function or the equation of our horizontal asymptote will be equal y is equal 0. So here we have example 5. Determine all vertical and horizontal asymptotes that the graph of fx is equal over root 2 minus x has. So we need to find or determine all the vertical and horizontal asymptote. For the vertical asymptote, we need to find the zeros of the denominator where they are not 0 for the numerator, or find the limit where the limit is approach to plus or minus infinity. For the horizontal asymptote, we need to find the limit as x approach to plus infinity and the limit as x approach to minus infinity. So let us do it one by one. So first of all, we have a function, our function is 4 over root 2 minus x. This function is continuous, or this function, the domain of this function, it is from minus infinity to 2. And here we have this graph of our function. And for the horizontal asymptote, we said we need to check the limit when x approaches to plus infinity or minus infinity. Since this function is defined only for the interval minus infinity to 2, so just we need to check the limit when x approaches to minus infinity. So if x approaches to minus infinity, so we go to this direction, the graph of our function approaches to 0. You can prove this one either by this graph, so when x approaches to minus infinity, the result of your graph goes to 0, or use this one. 1 over x minus a power r when x approaches to minus infinity is equal to 0, where our r here it is half, so the limit will be 0. So we have a horizontal asymptote when x is equal to 0. And again, we cannot consider the limit when x approaches to plus infinity, since our function is not defined when x greater than 2. For the vertical asymptote, we need to check the zeros of root 2 minus x. The zeros of this one, 2 minus x is equal to 0, so x is equal 2. So the zeros are just only, you have one zero, which is 2. And since this function is defined on the interval minus infinity to 2, so just we need to consider when x approaches to 2 from left. So when x approaches to 2 from left, the graph goes to infinity. That's mean x is equal to is a vertical asymptote for this graph. يعني على أساس نحدد الفيرتيكال والهوريزونتال اسيمبتوت هنستخدم القواعد. فلما نجيب الهوريزونتال اسيمبتوت نجيب الليميت لما الاكس ابروش تو بلس انفينيتي او ماينس انفينيتي. هنا لاحظنا مجال الدالة from ماينس انفينيتي لحد 2. اذا احنا ما نقدر ناخذ لما الاكس ابروش تو بلس انفينيتي لانها الدالة غير معرفة، فبناخذ لما الاكس ابروش تو ماينس انفينيتي. طبعا من الرسمة لما الاكس ابروش تو ماينس انفينيتي نلاحظ ان الدالة goes to 0. اذا y is equal to 0 is a horizontal asymptote. في الفيرتيكال اسيمبتوت نجيب لما الناتج الليميت يساوي بلس او ماينس انفينيتي. بنجيب اصفار المقام، نلاحظ ان اصفار المقام اللي هي بس 2 minus x is equal 0، اذا الاكس تساوي 2. الدالة معرفة من ماينس انفينيتي لحد 2، اذا بنجيب الليميت لما الاكس approach to 2 from left. لاحظ ان لما نجيب الليميت لما الاكس approach to 2 from left الناتج يطلع عندنا infinity. اذا بما انه ناتج infinity اذا الاكس is equal to is a vertical asymptote. Note here, in general, if fx is equal f over g, then the following table summarizes the limit results for the form limit of fx when x approach to a, limit of fx when x approach to infinity, limit of fx when x approach to minus infinity, where the symbol L denotes a real number. So if the limit form when x approach to a is equal when x approach to a or infinity or minus infinity, if it is L over plus or minus infinity, the result will be 0. If it is plus or minus infinity over L, where L is not 0, so we conclude it is infinite. If it is L over 0, where L it is not equal to 0, also it is infinite. يعني إذا كان limit لما نجيب limit لما الأكس approach to A أو infinity أو minus infinity، الناتج يطلع عندنا L over infinity or L over minus infinity، بنقول limit is equal 0. بينما لو كان الناتج plus or minus infinity over L، بحيث إنها L ما تساوي 0، إذا الناتج بنقول infinite اللي هي infinity or plus minus infinity or plus infinity. أما في حالة إنه كان L over 0 على طول نقول it is infinite اللي هي infinity plus or minus infinity.